Good morning all. I have sent about 3 mail to our Google Classroom, but yet nobody has responded to it. So I would advise you to keep checking your, for updates. Keep checking your Google Classroom for an update. So as I've said earlier, we're going to have a class today during our normal period. So it's going to be through video record. I intend to make it a video classroom through Google Meet, but due to some problem that I've noticed earlier from some of our students, some will come up online and then later they will go off. So I decided to make a video and send it to you. We're going to start by solving the recent assignment that I gave you. We start by solving it. This is same as saying we've started our revision. So this is your assignment questions, and according to the script I marked, almost 90% have solved question 1 perfectly. So I think I'll just skip question 2, which is the question says find the current and voltage drop in a circuit below using superposition theorem. So if you look at the circuit very well, you see that we have 3 loops, 1, 2, and 3, but only 2 of the loops have power sources attached to it. Same as saying we have electromotive forces 2, 40 and 50 volt. And then the upper loop, if you look at it, it only have resistors. Same as saying we have potential difference all across. So, but if you look at it carefully, you see that the upper loop can be reduced to 1 resistor. We have 3 resistors here, which can be reduced to 1 resistor. These 2 resistors are in series and both in parallel with this. We can start by taking the summation of this, which is same thing as 5, and then we take the equivalent or the total resistance, which is 5 in parallel to 5. So this can be done. Okay. This can be done by this. So the total resistance is going to be 2.5 ohm. You can now remove the loop in the upper part and replace it with this 2.5 ohm. And now the circuit is going to change to this. And here we have 2 in series now, which can also be reduced to 1 resistor. By adding 2.5 with 4 ohm, we'll change to a 6 ohm resistor, 6.5 ohm resistor. So your circuit has reduced to another form with just 2 loops now. So the next step is to now short one of the power source and leave one open. After solving, finding the current drop across all the resistors, we now move to the other one and short the other one. So now we start by shutting down 50 volt, and then we'll leave 40 volt connected. So this is our new circuit now, one-sided. So the next step is to assign our current direction. When current comes from 40 volt, at the first junction, we should expect it to divide. Some will go through the 6 ohm and some will go through the 6.5 ohm. So as you all know, when you have current coming at a junction, it divides and you're going to have different current. So if for instance we have our current as I1, some goes through 6 ohm, which is I2, then the remaining length or the other length we're going to have I1 minus I2, which can also be denoted as I3. So then our loop is going to start by taking the positive terminal for the power source, and then we take it to both 2 loops. So and also, if you can recall, Kirchhoff law required only the application of Kirchhoff loop rule for voltage. No application of current law. You only apply loop rule. And for loop rule, the number of equations that you should expect depend on number of loops. So we have 2 loops, we should expect 2 equations. So equation from the first loop, we have 40 volt coming from the positive terminal. And also current and loop I1 has no resistor in it, so we don't have potential difference in that position. We skip to I2. In I2 position we have 6 ohm, and also the current is going toward the same direction with the loop, so we take minus 6 I2. We don't have any other potential difference and also no electromotive force, so we equate it to 0, and that would be our equation 1. So in equation 2 we go to the second loop. You can start from any of the 2 resistors, either 6 ohm or 6.5. Remember, we don't have any electromotive force in our second loop. So our first potential difference, I choose to take 6 ohm, which is opposing the loop, so we take positive 6 I2. And then for 6.5 ohm, the loop and current are in same direction, so we take negative 6.5 into I1 minus I2 instead of just I3 to make it easier. So we equate it to 0, and this should be our equation 2. And also, by making I2 subject formula in equation 1, our I2 becomes, yes, fraction 40 divided by 6, and then we stand at 6.67 ampere. And then by substituting that same value, 6.67, into equation 2, we're going to get I1. Then I1 will be 12.83 ampere. And if you look at the second loop, we already defined I3 to be I1 minus I2. So by subtracting I2 from I1, we'll arrive at 6.15 ampere. So we're done with the current drop, or current flowing through each of the resistors in circuit 1. We'll move to circuit 2. This is our circuit 2. So we can now, if you can recall from our circuit 1, this I3 is in its initial position from circuit 1. And also, don't forget to make sure that your current look the same on the circuit, irrespective of which of the power source is connected or not, but the current should be the same. Remember, I3 is in this position, I2 is in this position, and I1 is in this position initially. So you make sure it remains the same. So now the current is coming from 50 volt, the same as saying I3 is our maximum current coming from the power source. So it goes through, and then some portion of I3 will go through 6 ohm, and then some will go through the non-resistor loop or non-resistor conductor. meaning we don't have potential difference. We can call it I1, which is the same as I3 minus I2, or I2 being removed from I3. So our loop now, we also choose the positive terminal to take our loop. So recall, if you can recall, superposition theorem required only the application of Kirchhoff's voltage law, which is something as Kirchhoff's loop rule for voltage. We now state our law: summation of electromotive force and potential difference within a closed loop is equal to 0, must be equal to 0. So our 50 volt coming through, and then 6.5, if you look at it, the loop and the current are in same direction. And then equation 2, we don't have any electromotive force in that loop, so we take the summation of our potential difference, and according to that path is going to be 6I2 equal to 0, because we don't have resistance or copper, so we only have one potential difference equal to 0. Substituting I2 in 1, we get the value of I3. Remember, I2 is 0. By substituting in equation 1, we're going to have I3 as 7.69, and also by substituting, we have defined I1 to be I3 minus I2, so by substituting the value for I3 and I2, we'll arrive at I1, which is something as I3. Okay. So now we have found I1, I2 and I3, and these are the directions of current in I1, I2 and I3 when 40 volt is connected and when 50 volt is connected. So now we're going to use the direction of the current to calculate the total current I1, total current I2 and total current I3. So how do we do that? We go back to our circuits to find the direction of current I1, I2 and I3 in both, or when both, this is when both 50 volt and 40 volt is connected to our circuit. So what do we expect the total current to be when both the two power sources are connected? So we go back to see the direction and then get back to our final solution. So this is current I1, I2 and I3 when 40 volt is connected, and these are their directions. So for the second loop, for the second circuit when 50 volt is connected, also these are the direction of the current. So if you look at the direction of the arrow here and here, you see that they are opposing each other, which is something as saying the larger current will subtract the smaller current, and that would be the total current in I1, and it's going to take the direction of the current with the larger value. And also for I2, if you look at the two current are in same direction, same thing as saying they are summing up, and if you add up this with 0, you arrive at the same thing. So this is the total current flowing through when both through the resistor at the center when both the two power sources are connected. And then for I3, also, if you look at the two currents are opposing, we subtract the smaller value from the larger one, and this is same thing as saying the current direction will take that of the larger current. So for you to calculate the current, the voltage drop in each, all you have to do is to use Ohm's law, which states that which state V equal to IR. You already have your I and you know your R in position 1 and 2. So you may be asked to calculate the current, the voltage drop through so resistor. So all you have to do is to look at the current flowing through it. Since you've known the direction, all you have to do now is to use the current to calculate the voltage drop. So thank you. This is the solution for your question 2. And also, please, I would like to say a few things. I suggest somebody should open a WhatsApp group for us. I believe you have all our contacts, and if you check my lecture notes, I usually add my contact to it. So for easy communication, I think that would be a good idea. But if your base email also is not connected to your phone, so please try and do so that you'll be able to get an update. As soon as I send something, you'll be able to receive it. You will receive an alert and then you'll go through it. So please try and do that and stay safe. No moving around. Stay at home. Thank you very much and have a good day.